Welcome to Chem Plus. Welcome to Chem Plus. Today we've decided to look at nucleophilic substitution. The very first thing that we're going to do is to look at different nucleophiles. We have picked those 4 nucleophiles. If you take a closer look at the nucleophiles, there's something that is common in all of them, right? What is it? They all have a lone pair of electrons. They all have a lone pair of electrons. So in your opinion, what is a nucleophile? What is a nucleophile? What is a nucleophile? It is an electron pair donor. Now, if we look at this chloroethane, we will see that the molecule is polar. And again, why is it polar? Why is chloroethane polar? We know that in that bond there, electrons are not shared equally. Chlorine is more electronegative. That's why the bond is polar. And your nucleophile tends to attack the positive center. Nucleophiles are therefore ions or molecules strongly attracted to a region of positive charge. Now let's look at the actual mechanism. The bond is polar. We've already touched on that. Your nucleophiles there attacks the positive center. As that happens, this bond here starts to break as well at the same time. This bond here starts to break at the same time. And what do we form? That's your nucleophile. The lone pair of electrons on the oxygen atom form a bond with the carbon atom. That is some kind of dative covalent bond being formed there. But the electrons being shared in this bond move on to the chlorine, breaking that bond. I think it's some kind of heterolytic fission happening there. Then what do we form? We form ethanol plus the halogen halide. The Kelly arrows show the movement of electrons from the nucleophile to the positive center. Now then, what affects the rate of nucleophilic substitution is the bond strength of the C to the halogen atom, right? We can clearly see that the Ci bond is only 238 and the Cf bond is 484, right? So it will be much easier to carry out nucleophilic substitution on compounds containing iodine, right? The Ci bond is the weakest and readily undergoes nucleophilic substitution. So what we are saying here is, if we've got those two compounds, I'm failing to pick my highlighter. The Ci bond will undergo nucleophilic substitution much easier than the fluoroethane, because this bond here is weaker. This bond here is easier to break. So ease of hydrolysis increases, ease of breaking down those bonds increases as you go down the group. Yo!